Hi, I'm Saud Alam, a web and data scientist of Wayback Machine at the Internet Archive. Today I'm going to talk about CDX Summary, a tool for web archival collection insights. At the Internet Archive, there are numerous collections of various media types like images, like books, video, audio, data, and whatnot. These items are organized in various collections and sub-collections. Some collections, like collections of books, images, and videos, they generally have rich metadata, distinguishable cover art and thumbnail, title, author, year, and other metadata listed in their item listing. However, when we go to web collection like this media cloud collection, we see that all the items have the same generic thumbnail, and their titles look similar in machine generated. Web collections are the ones that power Wayback Machine. There is an About tab, so if we click on that one, we get to see a limited set of metadata, but it still does not tell a lot about the contents of the archived web pages. For example, one might want to ask a question like how many captures are there in this collection, how many unique URLs or domains, and what else might be reported here. So recently, we have added much more insight of these web collections. If you go to some of these web collections and scroll further down, you will see various metadata and statistics reported for these web archival collections. Before we tell you how we generated and included this information, let's talk a little bit about how web archiving works and what is in these web archival collections. So on our left, there is a web page rendered in a web browser. One might argue that we take a screenshot of it and save it. That would be one form of web archiving. Yes, but it will have limited interactivity. Links will be lost. And one would not know how this page would have been rendered if it was loaded in yet another web browser. So one can also save the page source as shown on the right-hand side. And this is something that happens when you use save page as feature of web browsers. They save all the page source and corresponding page requisites like images and CSS and whatnot. But it still misses a lot of information, like when this page was archived, right? So let's load the same page using curl. On the left-hand side, we see there are a bunch of HTTP headers there that tell like which engineer X was the server that was used. Text/HTML was content type. Friday, 3rd August 2028 is when the response was generated. And there are a bunch of other HTTP headers included there, in addition to the payload that we saw in the browser. In order to save this, we actually put another layer of headers. We call them WARC headers, as shown on the top of right-hand side image. These are the metadata that the crawler itself adds, not the web server. With WARC header, HTTP headers, and payload put together, this makes a WARC response record. There are other types of WARC records, and various of these WARC records can be concatenated one after the other to make a single WARC file with many WARC records in them. Now, a replay system needs to know which particular WARC file a specific capture is stored in and after how many bytes. For that, we create something called capture index or CDX files. Replay systems like Wayback Machine rely on these CDX files to locate resources in the WARC file. So on the left-hand side, we show a WARC file that has two WARC records in there. These two WARC records are then indexed as shown on top. The CDX file is a text file format with multiple columns in there. These columns have a URL key, which is a canonical form of URL. It's also called cert. Then there is 14-digit date time, original URL without any canonicalization, media type, status code, content digest, number of bytes in WARC file for that record, offset of bytes from the beginning of the WARC file, and the WARC file path itself. There might be other columns added in specific CDX files. Then these CDX files are sorted. The first two columns, the URL key and date time, these act as a key, like lookup key. And since it's sorted, so binary searches can be performed. We take these CDX files with millions of records and sometimes billions, and we use this for summarization. We use CDX files instead of WARC files themselves because these are many orders of magnitude smaller in size. So for summarization of these CDX files, we built a tool called CDX Summary. This is a command line tool that can ingest these CDX files and generate reports on the command line itself in a human readable format with colorized text and tables. But it can also generate JSON files. So instead of seeing report on terminal, one might generate a JSON file and then load it in an HTML page using a web component that we created called CDX Summary. And whether the report was generated on command line or rendered in an HTML page using our web component, it will have same set of reports. So it will first have a section about overview of the entire CDX data. That would report number of total captures, unique URLs, unique hosts, the total size of WARC records, the first and last capture date. Then it has a section on MIME types and status codes. So in this section, one can learn how many HTML pages are there that return 200 OK responses. Hovering over on one of those cells of numbers will represent the number in other formats like percentages or localized string format. Last column and bottom rows are totals of MIME types and status codes. Similarly, there is another section that distributes statistics across path depth and query parameter. So for example, when you say P0 and Q0, that means there are 0 path segments and 0 query parameters, which is root URL. Similarly, there are other cells that are reporting for different path depths and different query parameters. Then we have a temporal distribution of these captures. In this case, the particular collection started in June 2016, and then it stopped. There was no activity in 2017. Then it was resumed in 2018 May, and since then it's been archiving regularly every month. We then represent a section of top hosts, like wp.me in this case was the highest contributor to these captures with 11.5 million captures. And the second one is upload.media, wikimedia.org. And there are total more than 5.4 hosts in this collection. Another interesting piece of information that the CDX Summary tool generates is a random set of URLs that are HTML pages with 200 OK responses. These small sample sets can then be used for spot checking for QA or just to understand what is in this collection. On the right-hand side, these thumbnails are not static images. Instead, these are a random subsample of these sample URLs that are then loaded from the archive in small iframes for rendition. We also make these the CDX Summary web component available for anyone to use. But in order for them to customize and adjust it according to their need, we also created a testing and customization tool. So here they can provide what kind of date format, number formatting they want, how many thumbnails they want, background color, text color, border color, and all sorts of other style customizations. Then from the bottom left corner, they can copy the code and use it in their HTML to render their own CDX summary component. In the future, we would like to generate statistics on unique URIs. We would like to render visualizations, not just tabular numbers. We want to improve the scalability when it comes to a lot of hosts our tool is currently storing in the memory. We want to make it more scalable. And we would like to look for ways of incremental updates. Right now, it requires redoing the whole collection every time new data is added to the collection. We would also like to have some heuristic-based highlights for users to take away home. So in conclusion, we have created a CLI tool for archival CDX files and API summarization. Our tool generates reports in human and machine friendly format. It provides varying levels of detail. It can be used for collection understanding and quality assurance. We have an efficient random URL sampling technique implemented in it. And then we provide a custom web component and a web component testing tool. Our code and tools are open source. They can be